Hey guys, welcome to our next video in Chapter 11. This video is all about the volume of pyramids and cones. Right off the bat, I want you guys to understand that calculating the volume of a pyramid or a cone, they're extremely similar to one another, just like calculating the volume of a prism or a cylinder was super similar to each other. On top of that, we can actually go even further, and we can say that the volume of a pyramid is very closely related to the volume of a prism. Same thing with cones and cylinders. So everything kind of ties itself nicely together. So hopefully by the end, when we're getting towards the end and we're getting ready to take our summative, you're going to see these connections, and it's going to be kind of easy for you to put all of this together. So here we go. The volume of a pyramid is related. The volume of a pyramid is related to the volume of a prism with the same base and height. This relationship can be verified by dividing a cube into 3 congruent square pyramids. Now, just looking at this picture, I would completely understand if you're a little confused by it. I get it. I'm a little confused by it. What they're really doing here is they're taking this cube and they're kind of picking a point and they're splitting the cube into 3 separate pyramids. What's nice is, because all of the pyramids have the same base, because again this was a cube, so that means that all of the bases are congruent squares, and they all have the same height, well, we know that they're going to have the same volume then. So if I'm splitting one object into 3, that means that each object is going to have 1/3 of the original volume. Again, if that doesn't quite make sense, don't worry. I'm going to do a different example in class that hopefully will give you guys a chance to comprehend this and understand this a little better. So for right now, let's move forward, and let's say that the square pyramids have to be congruent, which means they have the same volume. Each pyramid, that is. The volume of each pyramid, as we kind of mentioned above with our 1/3, is 1/3 the volume of the cube. So now that we've kind of talked about that, we can come up with our formula for the volume of a pyramid. All right, the volume of a pyramid with base area, capital B, and height, h, is V equals 1/3 capital B, h. Now hopefully you guys recognize, we've seen this before. This is what we use for prisms, and it's actually what we use for cylinders too. The only thing that we really have to think about is that we're tacking on, or we're taking 1/3 of a prism, or 1/3 of a cylinder. So just like we did for a pyramid, we're going to do the same for a cone. The volume of a cone with base area, capital B, radius r, and height h is V equals 1/3 capital B, h. Now, the one other thing I want you to keep in mind is we know that a cone is always going to have a circular base, so we can always use pi r squared as the area of the base, which means we can plug that in, and if you would like, you can always remember the volume of a cylinder to be 1/3 pi r squared h. Again, this is all you need, V equals 1/3 bh. But if you would like to kind of remember this formula, that is more than okay as well. So let's get into some practice. As we look, we start you off with what I consider a terrible picture. All right, I think this example is very difficult to see, but I'm hoping that we can fight through it, work together, and figure out what's going on here. Now, if I look at this, I need to name, I need to find the volume, remember to round to the nearest tenth if necessary. What I'm actually looking at here is a I want to use green, sorry. Trapezoidal pyramid. How did I know that? Well, I'm definitely seeing this trapezoid, A, B, C, D. And if you notice, all of these other sides, all of these other faces are triangles. Okay, so if I have one trapezoid and all of the other faces are triangles, that should be my hint that I'm looking at a trapezoidal pyramid. Once I figure that out, I know that I'm going to use V equals 1/3, capital B, H. I've been suggesting, I can't force you to do this, but I really strongly suggest sketching the base. Okay, I strongly suggest this. So 18, and this is 9, and I know that the height is 6. I do this because for me that helps me stay organized, and it helps me know that I am solving for the area of that base. So that is what big B is going to be. So now I know that the area formula for a trapezoid is 1/2 times the height times base 1 plus base 2. Just a word to the wise, remember this H is not the height of the pyramid, it is the height of the base shape. So in this case, when we plug in B equals 1/2, I'm going to use 6 for the height, and then I'm going to use 9 and 18 for both of the bases. When we go to the calculator, 0.5 times 6 times 9 plus 18, oh, I got to put an extra parenthesis in there. We end up getting that the base area is 81. Now that we have the base area, I'm ready to go to my volume equation. Alright, I know that the volume is going to be equal to 1/3 times that base area that we just solved for, and then the height of the pyramid. Now, again, this is where I find the picture to be a little goofy. What they're wanting you to try and recognize is that this letter E is kind of going back into the distance. So what they're going to say here is that these two angles right here, EAD, BAE, whichever one you want to look at, those are perpendicular, which means that EA, that length of 10, is perpendicular to the base shape, perpendicular to the trapezoid. So that means that I'm going to go ahead and I'm going to plug in the height of 10 right there. At this point, it's all calculator. 1/3 times 81 times 10, 270. 270 meters cubed. I'd write it on the line and I'm done with that problem. Now, number 2 is going to be way more straightforward. We have everything we need. V equals 1/3 BH, capital BH. Notice I'm using the same formula just to get in the habit of using it. If you would like, you can just use pi r squared. But here we go. I know that the base shape is a circle, and I know that if the diameter was 6, then my radius is 3. Which means that when I go to find the area of the base, I use pi 3 squared. And my bad, let me just rewrite that formula so you guys know what I was doing. So now I know that my base area is just 9 pi. And I'm ready to go to the formula now. The volume formula. 1/3 times the area of the base, or 9 pi, multiplied by the height, or the height of the pyramid itself. So that is the perpendicular distance from the base to the top of the cone, sorry. I think I said pyramid earlier. It's the perpendicular distance from the base to the tip. So this is a 9. Now I go to the calculator. 1/3 9 pi times 9, 27 pi. This I would probably leave in terms of pi. Yards cubed. Alright, I'm very sorry guys, this is my fault. I kind of skipped a step. Hopefully we can all recognize that this is just a cone. Alright, so now moving on to the next problems. These next problems are going to require a little bit more work. Alright, if I look at something like 14, I would say that this is a square pyramid. How do I know? Well, this base shape is a square if both sides are 40. And I know that all of my edges are meeting at one point. There's only one base. So here we have a square pyramid. Now it's time to get to work. Again, V equals 1/3 base area times height. Well, if I look at my base, it's a 40 by 40 square. So I know that capital B is just going to be 40 times 40, or capital B was base times height. That would give me a base area of 1600. So now, when I go to plug in, what are we noticing? We don't have the height. This is a situation where you're going to have to recognize, well, I have enough to solve for the height. Please notice what I'm highlighting right now in red. What I'm going to do is I'm going to kind of pull that triangle out of the picture. Okay, not the best picture, but it'll do. I know that the hypotenuse there is 25. I also know that I'm looking for that height. What I need you guys to recognize is that from the very tip of my pyramid down perpendicular is going directly to the middle of the base. So that means, well, this length has to be half of the side length, or 20. Now we have two sides of a right triangle. Hopefully I don't need to explain what I'm doing now. Pythagorean theorem. 625 equals h squared plus 400. 225 equals h squared. H equals 15. Now I know what to put in for the height of my pyramid. And I go directly to the calculator. 1/3, 1600, 15, boom, 8,000 feet cubed. And I'm done. Similarly, in number 4, we're gonna have to do something very similar. If I look again, I can go V equals 1/3 capital B H, and I can draw my base, and I know that the radius is 16. So I know that I'm going to have pi 16 squared. So I know that the area of my base is 256 pi. Now before I even start plugging in, hopefully we can see I don't have the height. So once again, I'm going to need to come over here and kind of sketch the triangle that I see. I know that the hypotenuse is 34. I know that the radius is 16. I know I'm looking for h. So I set it up. 34 squared equals h squared plus 16 squared. Now 34 squared is 1156 h squared, and then 16 squared is 256. So this becomes 900 equals h squared, or h equals 30. So now I know that I can plug in 1/3, 256 pi, and I can plug in a height of 30. When I go to the calculator, 1/3, 256 pi, 30, I get 2,560 pi, and I'm cool with that answer. Centimeters cubed. And once again I goofed up. Here we go. We should know that that's a cone. Alright, so these are good examples of problems you might see where you are solving for the volume of a pyramid or a cone. Lastly, you guys know what's coming. We have these problems that we've been testing your algebra skills on, where you really need to focus. Sorry, trying to zoom. Where you need to focus on finding one single measurement. All right. So let's start with number 5. We're trying to find the height of this pyramid. All right. Pyramid. That means I use 1/3 capital B H. Now, I probably need to get capital B so that I can plug in and figure out what the height of this pyramid is. So let's take a look. If I either sketch or highlight the base shape, we should see that it is a right triangle. And please note that across from the right angle of the triangle is 10, which means my sides have to be 6 and 8. All right? So, capital B, I have a perpendicular height to the base. So I do not need to use 1/2 AB sine C. I can use 1/2 BH or 1/2 times 8 times 6, or 1/2 of 8 is 4, 4 times 6, 24. Now I'm ready to go. Now, I knew the volume was 72 from the information. 1/3 times 24 times the height. Guys, this comes back to your algebra skills. I know that I have 1/3 times 24 times h, so I'm just going to multiply these two things together. Remember, multiplying by 1/3 is the same as dividing by 3, so this actually just turns into 8h. And then when I divide both sides by 8, I end up getting that the height is 9 centimeters. Last problem. Thanks for sticking with me. I appreciate it. We have a cone. And I know that the volume is 486 pi. I know the height is 18. Let's plug that in and figure out what we can do. If I know that the volume is 1/3 times the base area times the height, then I can say 486 pi is equal to 1/3 times the area of the base times 18. Very similarly to the problem before, where I could do 1/3 times 24 before multiplying by h, I can do the same thing here, and this caused problems on the test. You guys have to remember that we can multiply in any order. So I'm going to multiply 1/3 by 18. 1/3 times 18 is the same as 18 divided by 3, or 6. So, when I divide both sides by 6, I end up getting 81 pi is equal to the area of the base. Almost done. What can we do? We're trying to find the diameter. Sorry, I highlighted something you couldn't see. We're trying to find this diameter, which means we probably need the radius first. Okay? Well, we have a formula for the area of the base. I'm going to plug it in now. 81 pi is equal to pi r squared. What happens when we divide by pi? The pi's cancel. So I have 81 equals r squared. When we square root both sides, we end up getting that r is 9. Hopefully I don't even need to show my work, and we can all just agree that my diameter, if my radius is 9, my diameter has to be 18 inches. Alright, so there were some good practice problems, all problems I would expect you to be able to do on a quiz or a test. Again, what I really want you guys to take away from this unit, or from this section I should probably say, is that pyramids and cones, 1, they're the exact same calculation, and 2, they're very closely related to prisms and cylinders. So there we have it. That was 11.3, volume of pyramids and cones. Next time we meet, or next time you guys listen to my video, we'll be talking about spheres. Thanks very much for watching. I'll see you guys in class. Peace.